Okay, so just a quick lesson update on what we did in class today. Today's Friday, October 16th. So today we just went and continued on with the tangent, cotangent, cosecant, and secant graphs. So we already did tangent, we did cotangent the other day, and we did just one example problem. So we kind of warmed up using some other problems. Honestly, these problems they're going to be pretty straightforward. I'm really not going to do anything quite as crazy as when we did sine and cosine. So if you know how to change the a value and if you know how to do a period shift works the exact same way. So you'll see here in this example, I set the inside equal to 0, I solved, and it looked like I'm going right pi over 2. That means I'm going to take the original tangent function and I'm going to move it to the right pi over 2, just like this. Okay? All of the new lines are going to change with it. So the asymptote used to be at pi over 2. The asymptote gets moved over to pi. So all of those things are going to get shifted. Okay, so from there, oh, I guess I can't click. Okay, so from there, we practiced some more. This one is pretty simple, so we're going to keep on going. We practiced, here we go. All right, so the new graph that we visualized today was the cosecant graph. So the cosecant graph looks like this. It's actually the yellow graph. It's not the blue graph, so I don't know why I wrote that in blue. It's the yellow graph. Cosecant is such an interesting looking function. You'll see that there are so many asymptotes. There's infinitely many asymptotes, and the asymptotes are happening in intervals of pi n. So basically, these asymptotes are happening when I think about why an asymptote happens. An asymptote generally happens because there's a 0 in the denominator. So let's think about this for a minute. When sine of x is 0, let's think about how sine and cosine are related. So the reason I had students graph sine first is because sine is the inverse of cosecant and cosecant is the inverse of sine. So I wrote this here. Cosecant is equal to 1 over sine. So when sine is equal to 0, cosecant is going to equal 1 over 0. Well, we did a huge proof the other day that 1 over 0 results in an undefined solution. In fact, it results in an asymptote. So anytime that my sine function crosses the x-axis, I am going to get an asymptote. In addition to that, anytime that sine has a maximum or sine has a minimum, I'm going to form these parabola-like shapes. Now, they're not really parabolas, but I'm going to form these parabola-like shapes that follow the asymptote all the way up to infinity. So this is what the cosecant function looks like. It's the red function here. So cosecant follows these asymptotes, and they start on maxes and mins of sine. So in essence, if you want to successfully graph cosecant, all you need to do is graph its inverse sine, create some vertical asymptotes, and then create your U-shapes on mins and maxes. Okay, sorry for the noise out there. All right, so for the next function, we have the secant function. Secant, if I remember, and I don't think I wrote this here, secant is the same thing as 1 over cosine. So if you can graph the cosine function, you can totally graph the secant function. Notice how I have asymptotes in intervals of pi over 2. So I have asymptotes that are in intervals of pi over 2. Let's think about this for a minute. Cosine of pi over 2, on my unit circle, that equals 0. So if secant is 1 over cosine, then when cosine is 0, secant would be undefined because 1 over 0 is undefined. It creates an asymptote. So the secant function works the same as the cosecant function. I'm going to graph cosine. I'm going to create asymptotes anytime I cross the x-axis. Anytime that cosine is 0, I'm going to create an asymptote. And then I'm going to form my U-like, parabola-like shapes that follow the asymptotes, starting on the minimum and starting on the maximum of both my my cosine function. So basically, graphing secant, it's pretty self-explanatory. If you can graph cosine, you can graph secant. Biggest thing here, the period of secant is the same as the period of cosine. It's 2 pi. Same thing with the graph of cosecant. Cosecant is really, really similar to the sine function, and the sine function's period is 2 pi. So last thing here, the asymptotes. Asymptotes are going to happen in iterations of pi over 2 plus pi n. That's kind of a throwback to tangent. Tangent also has asymptotes on pi over 2 plus pi n. So that's just kind of a fun fact there. All right, let's go ahead and let's keep on moving. The next thing that students did is I just defined generic forms of the cosecant and secant functions. This was really quick because honestly, it's the same as sine, same as cosine, same as tangent, et cetera, et cetera. Same thing here. If you want to find a period shift, you need to set the inside equal to 0. In addition to that, the periods for cosecant and the periods for secant, are 2 pi over b. So same thing as sine and cosine. To find the period, you're going to take 2 pi and you're going to divide it by b. Okay? All right, let's go ahead. There's just a couple practice problems today. So all I had students do was basically, if I'm going to graph cosecant of 2x minus pi over 2, if you can graph sine, oh boy. If you can graph sine of 2x minus pi over 2, you can totally graph cosecant. So I had students graph sine of 2x minus pi over 2, create asymptotes anytime, I need to stop doing that. Create asymptotes anytime that, I messed it up. I'm sorry. Let's see if I can get this back. There we go. Create asymptotes anytime that my sine function crosses the x-axis or is 0. And then from there, at mins and maxes, that's where I'm going to start these U-like parabola shapes that follow the asymptote. All right, so we did a couple example problems here. There was another one where we changed the amplitude and we had a horizontal shift. And then there was another one using the secant function where I just had a period shift of pi over 3, and I changed my period to 2 pi over 3. So basically, if you can graph sine and cosine like we did on the quiz the other day, you are going to be just fine with secant and cosecant. So that's all we really got done today. You did have a homework assignment. I'm going to have to put it on Classroom. The homework assignment is it's worksheet 4.6a, and it basically just deals with cotangent and tangent. We'll deal with cosecant and secant later. All right, if you have any questions, feel free to email me or send me a reminder. I hope that you have an awesome time at your tournament. Go Blue Devils.